Hi everyone, so look at this paper 2 of the section B. So we're going to answer some sample question here from this section B. So we're going to start with this question 7 here. Alright, you can see the picture here. This one show you some of the application of the sulfur. Alright, and then you can see this is like a fertilizer. Alright, you can see the picture here is the sulfuric acids, and this one is actually the fertilizer, and of course this one is for the plants, for the trees. Alright, so every living thing always depends on each other. Plants will thrive and have leaves that are green, and it has enough nutrients. The supply of nutrients can be obtained from natural fertilizer or synthetic fertilizer. Alright, diagram 7 show the flow chart for the industrial manufacture of sulfuric acids and the production of 3 types of fertilizer. So there's actually a link between the sulfuric acid and a fertilizer. Okay. So look at this flow chart here. So here flow chart shows like step by step how you are going to make sulfuric acid and then the fertilizer. Alright, so start from sulfur, sulfur dioxide, substance X, oleum, sulfuric acid, lastly fertilizer Y. Okay, so in order for you to answer this question, first you have to know the theory for this. So this is actually an industrial process where you are going to make the sulfuric acids. So it has a name, it has all these underlying reactions you need to know, and you must know how to write the equations. So I'm going to start answering this question by first giving you some of the theory behind this. Alright, so first I'm going to give you a name for this reaction. So this reaction has a name. Okay, so you have to remember what is the name for these reactions. So the production of sulfuric acid in the industry, we call it contact process. So this process is actually known as a contact process. Okay, so it's an industry process lah. All right, and you can see in this flow chart here, actually it's happened in 4 different steps. Can you see or not? Use a pointer here. Let me just show you the pointer. 1, 2, 3 and 4. So it actually come with 4 steps. So in other words, I can say that the contact process happening in 4 steps. You can break down into 4 steps. 1, 2, 3 and 4. So the first step on this flow chart you can see is actually the sulfur becoming sulfur dioxide. So how do you make this change? So of course sulfur, you have to burn in air in the presence of oxygen, then you're going to get the sulfur dioxide. Okay, so the first equation that you must know is actually sulfur plus O2. We're going to get SO2. So make sure the O that you write is a capital O lah. Okay, understand? Alright, then the second step will be continue from SO2, and then you're going to get substance X before you come to oleum. So how do you make this substance X? And what is actually the identity of this substance X? So we know that SO2 can further oxidize in the presence of excess oxygen. So basically you continue from the SO2 here, and then you're going to write with excess oxygen, alright? And you're going to get something, we call it sulfur trioxide. So tri means 3, so it's an SO3. And this equation, as you can see here, is not balanced. So you have to balance this one. Alright, so I try to make the oxygen to be total of 6 on both sides. So here is already 2 sulfur. I need to put a 2 in front here. Alright, 2 sulfur, 4 oxygen, 2 oxygen. So overall total you get 6 oxygen here. Here also 2 times 3, 6 oxygen. So first step, production of SO2. Second step, you're going to make SO3. So I know already my substance X is actually my SO3. So I know already this one is SO3. Okay. So next we're going to proceed to the step 3. So the step 3 you can see is actually start from SO3, and then you make something, we call it oleum. So oleum is a name, but what is actually the formula behind this oleum? Alright, so you're going to continue again from the step 3, from SO3. Okay, so for this reaction here, you are going to make something, we call it oleum. Alright, so for step 3 is actually where you're going to produce something known as oleum. So we're going to start from SO3. SO3. So the sulfur trioxide is a gas, so the gas will actually have to dissolve in something we call the concentrated sulfuric acids. So you're gonna write H2SO4. Okay, so it's a gas dissolved in acids, and we're gonna get something, we call it oleum. So what is the formula for oleum? Very easy. You just combine all the H, S, and O. So H got 2, S got 2, and then the O got actually 7. Alright, so you can just compare here. 2S, and then hydrogen got 2, and oxygen got 7. So this is the formula for oleum. Alright, once again, step 3 is where you dissolve sulfur trioxide gas into concentrated sulfuric acids, and we're going to get a very thick liquid. We call it oleum. Alright, so then move on to your step 4. So step 4 is where you change oleum to sulfuric acids. So once again, I'm going to write down oleum. So basically, it's just continue from all the previous steps. SO2 here, SO3 here, and then oleum you bring to here. So we're going to get H2S2O7, and then it's a thick liquid, so very thick, very sticky. So means you're going to just dilute with water. So now you just pour in more water. So pour in more water, of course, you're going to get sulfuric acid because that will be your final products. Okay, here we don't use much. Here we use only a little bit of sulfuric acids. As I said, it's very thick liquids. And then lastly, you dilute with more water. Here we're going to get more concentrated sulfuric acids. Okay, so for this one, if you see that I rewrite H2SO4, but you have to balance. So you're going to get 2 of these sulfuric acids. Alright, so oleum dilute with water, we get concentrated sulfuric acid. So this is your final products. And then here, this is your last step, which is a different reaction. We call it neutralizations. Alright, acid with alkaline, of course we're going to get a salt. What kind of salt is this one? It's actually your ammonium sulfate. Alright, because sulfate salt must come from sulfuric acids. Alright, so next we're going to go into the questions here. So based on step 1 to 4, describe briefly the industrial process of sulfuric acids. Okay, so all this is actually the equation involved here. They don't require you to write the equations. Alright, they just want you to explain or describe in words only. So basically we're going to convert all these 4 steps here into a wording. Alright, so I'm going to answer now for your part A, part 1. Okay, so the first step, how do you explain in words? So you can just say sulfur is burned in air to produce sulfur dioxide. So you just write in words lah. Sulfur is burned in air or in oxygen to produce sulfur dioxide. So that is your first point. Alright, so I just put in point form. Okay, so because this one comes with 4 marks, so and you have 4 steps. Alright, explain briefly lah. Okay, second step is the SO2. So you can say what? Sulfur dioxide is oxidized. So this one is actually oxidations. Alright, so you can just continue here with the word sulfur dioxide is oxidized. Okay, oxidized to sulfur trioxide in excess oxygen. Okay, in excess oxygen. So that is your second step. Okay, I'm just going to move up a bit here. So now we're going to move on to the third step. Third step is where SO3 convert to oleum. So you just say that, continue here. Sulfur trioxide, which is a gas, okay, is dissolved. Alright, is dissolved in concentrated sulfuric acid, okay, to form or to produce oleum, O-L-E-U-M. Okay, so now we end in this step lah. So last step will be your step 4. So step 4, as you can see here, is the oleum convert to sulfuric acids. Okay, oleum is diluted Oleum is diluted with water to produce concentrated sulfuric acids. Concentrated sulfuric acids. So these are the 4 steps lah, and we explain it in words in a briefly manner. Okay, so if it's an essay question, of course you can include all the given reactions. I mean the equation for that. Okay, so I'm just going to scroll up here. All right. So now we're going to answer. We're going to answer for part B lah. Okay. So move on to the next part here. So part 2. Sorry. Okay. I'm just going to write in different color here. So I'm going to write in part 2 now. The conversion of sulfur dioxide to substance X is very slow. Okay, once again, what is your substance X? So means this. SO2 change to SO3 is very slow, they say. Alright? And the percentage of conversion is also very low. So means the amount of substance X, which is your SO3 that you are getting, is also very low. In other words, we say that the U is very low, right? State 3 ways to overcome these problems. Okay, so that's a question, 3 marks. Okay, let me show you again the equation for this step 2, because step 2 among here you can see all the 4 reactions here. The step 2 I will say is the most important step in this contact process. Okay, why I say that? Because this production of SO3 is very important. If you can get more SO3, of course you can get more oleum, and then of course you can get more sulfuric acids. So I want to maximize my production of SO3, and this equation you can manipulate. You can adjust by adding something, we call it catalyst, with the right temperature and of course with the right pressure. Why I say pressure is involved? Because you can see these 2 substances or these 2 reactants are gases. SO2 gas, O2 gases. So remember, we have learned it in Form 4. We do have the rate of reactions. So there are several factors can affect the rate of reactions. They will control the amount of product you can form. They can speed up the productions. Right? You increase the rate of reactions. So we somehow, they say, use 3 ways to overcome this, means to increase the rate of reactions, make it higher. So what we can do, of course, first one, temperature. Second one, of course, is pressure, because both reactants are gases. Thirdly will be your catalyst, the use of catalyst. Okay, so in the contact process, they actually has optimized the condition, and then we already figure out what are the temperature, pressure, and catalyst. So you have to remember all the given answer here. Alright, so for temperature, is not room temperature. Okay, so the temperature is also very, very high. It's not hundreds. So the temperature here is about 450 degrees Celsius. Of course, you are able to give in a range. As long as your answer fit into the range, that will be correct. I would say anything from 450 to 550 degrees Celsius will be correct. Okay, degrees Celsius. Secondly, they want 3 methods, right? So the second method will be the pressure. Okay, pressure here is not high pressure. It's actually the room pressure. So room pressure means is 1 atm. So 1 atmosphere. You want to write atm symbol also can, or you write in words. Atmosphere also can. Okay, thirdly will be the catalyst that I mentioned just now. So what is the catalyst involved in this? Okay, so for this, the catalyst is known as your vanadium 5 oxides. Sometimes they call it vanadium pentoxide. Okay, so or you call it vanadium 5 oxide. So the formula is, you want to remember, is HV2O5. So these are the 3 ways, all right, because this contact process, it must use these 3 specific conditions so that they can maximize the increase the rate of reactions. Okay, now we go on to the third part 3. Okay, Write a chemical equations for the reaction between sulfuric acids and ammonia to produce fertilizer Y. So sulfuric acid and ammonia, they want chemical equation. So sulfuric acid H2SO4 plus ammonia NH3. So I'm going to write on the next line here. So we're going to get a salt we known as an ammonium salt, right? So ammonium sulfate. So NH4 is plus, SO4 is 2 minus. Because this is 1 plus, this is 2 minus, the 2 have to be over here, crossover. So you have to include the brackets. Okay, so we call it ammonium sulfate. Okay, they only one equation, they don't want any name lah. Alright, so there's 2 for this. So of course, ammonia, you're going to put 2 in front. So then you get perfect 2 marks lah. Because if you don't balance or you forget to do that, you only get 1 mark. Make sure all the formula also correct. Okay. B now. The figure above show the iron nails and the stainless steel nail, right? Explain why pure copper is softer than its alloy. Okay, so for example, pure copper, and you compare with another alloy that made from copper. Okay, a bit theory first. What kind of alloy that you can have is made from copper? Okay, so very easy to remember. I'm going to just show you one of the guidelines here. So we have 2 different alloy that is made from one of the elements is actually a copper. So for example, we have one, we call it the bronze, and the other one we call it the brass. So bronze and brass are known as an alloy. So it's not a pure metal. It's a mixture of 2 or more different metal. So for the bronze, you're going to have something, we call it the copper. So inside both also have copper. So it's a copper plus, here you have an Sn. So here you have a Zn. So how I remember is that you can see that the Z is here. So here will be Z. It's like crossover. Can you see or not? Z here, Z here. It's S, right? So here is S, then here will be Sn. So it's a copper plus tin. Copper plus tin is bronze. Copper plus zinc will be brass. Okay? Alright, so come back to the question again. Explain why pure copper is softer than its alloy. So it means like why a pure copper is softer than, for example, bronze or brass. So how do you explain here? So first you have to say that pure metal. So I'm going to write the answer here. So for this one is actually your B, part 1 lah. So you say that the pure copper or pure metal lah. So pure metal atom have similar size and shape. For example, if I just referring to copper, they all have the same types, same size of atoms. Alright, so there's your first mark here, because this question come with 2 marks here, as you can see. Alright, 3 marks. Okay, so you can say same size, same shape. Alright, then you come to the next mark, you can say is what? I think this one should become to 2 marks only lah, not 3 marks. Okay, and then what happened to the atoms? So the layer of the atoms, those atoms that can easily slide over when you apply a force. Okay, so you just say that this atom are easier to slide over. Okay, that's it, straight to the point. So they are easily to slide. So therefore, they are actually considered softer. They are not harder. Alloy is harder compared to pure metals. Okay, put it smaller here. All right, we go on to the next question here. Okay, part 2, we are going to draw now. Draw the arrangement of atom in pure copper and its alloy. So we're going to draw a comparison here, because first you have to draw pure copper. So this is a picture for the pure copper. So how are you going to draw the pure copper? So make sure you draw those atoms of copper that must be the same size and the same shape. All right, so 1, 2, 3, 4, 5, 6. And then make sure you draw in layers. So the next layer not necessarily must be like straight away below it. It can be in the betweens. All right, you can draw like this. 1, 2. Okay, make sure they are touching lah. Right, it's a good way to draw that they are touching. All right, something like this. Okay. This is how you draw. So the examiner will see they are in the same size, same shape, and then they are in layers. You can see one layer, second layer, and the third layers. Okay, so that's your pure copper. Next, we're going to draw the alloy. So you cannot remember the name of bronze or brass. So what you can do, you can just write the name alloy lah. So alloy, now you introduce like two different elements. Like you have copper, beside that you also have either tin or zinc. So you're going to draw different size. Okay, so 1, 2, 3, 4. You don't need to draw in layer because I think the layer is no longer arranged properly already because you introduce a different elements. So different element you must show in different size. So maybe it's smaller. Okay, you just show like this. Maybe it's smaller. Somewhere random in between. All right. Something like this. So you can show something like, because you introduce a different elements inside already. Okay, just draw another one like this. So this is side. They are like jammed inside, so it's very hard for them to slide over when you apply a force. Let's say there are some pushing force, you push here, this layer can slide over. But for this, if you try to apply the force over here, this layer cannot slide over, sorry, because there's something blocking the way. So it's very difficult to slide over. So you can say that this is weaker, softer, this is harder, stronger. Okay, that's why we change a pure metal into alloy, because they are stronger, they are harder also. All right, so that is your part 2 answer. Now part 3. State the aim of alloying. So why we need to alloy? Okay, they want 3 marks, so means 3 points. Of course, to make it harder and stronger. So you can just say to increase the strength. Strength means stronger lah. And make it harder means you should increase the hardness of metal. Okay, so that's your first point. We want 3 points. Okay, beside make it stronger and harder, what else we can do? And of course, you know that beside copper and bronze or brass also we have another one. We call it like pure iron. Pure iron, then what is the name of the alloy that come from iron? We call it stainless steel. All right, so a stainless steel, inside it has iron, it has chromium, it has nickel, and it has carbon. So sometimes we introduce more than 2 elements in an alloy. So for example, stainless steel. The main one, of course, inside stainless steel is iron. They have other 3 things inside, which is your chromium, nickel, and carbon. All right. So why we make stainless steel? The name stainless steel. So it's actually to prevent or to resist the corrosions or the rusting. Okay, so the second function, the aim of alloying is to prevent the corrosions of metal. So once again, the word corrosion is for a group of, it's a general name for metal, but if you want to use iron or steel, better use the word rusting. Okay, so the rusting, this word is only for iron or any alloy that contain iron. So normally we use the word corrosions to prevent corrosion, pengkaratan. Okay, and how about the third aim? So like for example, you can see the bronze, the brass, these are normally used in decorative items so that they look more attractive, look more beautiful. So of course, the third reason why we make alloy is to improve the appearance, so they look more attractive. Okay, that will be the third reason. Okay, go to the next question here. State the alloy suitable for building bodies of plane and give a reason for your answer. Okay, this is now my part 4. This is come with 3 marks. So they want plane means to make a plane. So you have to give the state the alloy. So means you need to know exact name what is the alloy. So it's not stainless steel because okay, A-plane of course you know is very light, it has low density. So what is the major composition of metal? Definitely will be aluminium because aluminium is a very light metal. But we want to make the alloy come from aluminium. So there are 2 answers you can give here. First you can say it's actually the aluminium going to mix with the magnesium. So they form an alloy. So what is the name? So I just write symbol here is where you have aluminium with magnesium. What is the name? We call it. It's like Magnolia, the ice cream name, but here just change to Magnalium. Okay, so that's the name of this aluminium. Okay, so if you can remember Magnalium, then will be very good. Actually, they also have another answer you can give. Beside Magnalium, we call it the duralamine. So it's actually also contain the aluminium. So it's actually your aluminium, but this time you're gonna mix with the copper. So we call it the name duralamine. So the lamine seems like an aluminium is inside. So there are 2 alloys of that contain aluminium. One is magnalium, one is duralamine. Okay, so these are the name of alloy. So you have to give either one of these 2 names. All right. So and it since it's contain aluminium, so I can say like about 90 above 80 or 90% of the alloy mainly will be aluminium. So I can say these 2 alloy, they are also very light and low density. That's why it's actually a good reason for them to make for plane, because we want it to be not just light, we want it to be strong and harder also. So that's why alloy is used to make to build body of planes. Okay, give a reason. Okay, first reason because it's stronger, and harder. Okay, that is the first reason. And then the second reason, it can withstand compression or air pressure, because you know when you travel in the plane, you go to higher altitude, it's high pressure, so it must be able to withstand high pressure or to withstand compressions of air. Okay. All right, next we go into the next question here. We go to question 8. Let me just scroll up here. So now for question 8, let me just read up the question for you here. This is the question number 8 and then part A. Alright, dilute ethanoic acid, so we call it the vinegars, is electrolyzed using a carbon electrodes. What is produced at the cathodes? Write a half equation for the reaction. Right, persamaan setengah. So we are having an ethanoic acid. So ethanoic acid's formula is CH3COOH. All right. We also call it a vinegar. So this one is an acid. All right. And you are going to electrolyze using an inert carbon. Here we call it a carbon. So carbon, platinum, all these are example of an inert electrode. Inert means unreactive. All right. So what is produced at the cathode? So cathode means it's actually a positive or a negative electron. The word cathode means that the cation will attract to the cathodes. So cation is a positive. Positive, of course, it will attract to the negative. So the cathode here is actually the negative electrons. Okay, so make sure you are putting a positive ion attract to the cathode here. Okay, so we will just draw a very simple diagram how we're going to perform this one. We're going to have 2 electrodes here, and then one plus, one minus. The long one is plus, the short one is minus. All right, and then this will be inside your electrolytes. And this 2 electrode is made from carbon. Okay, so let's try to dissect or understand the underlying theory for this question here. So of course, electrolysis, the aim is to break down or separate the compound in your electrolyte into pure elements. So we do have two electrodes here. One is cathode, one is anodes. So the cathode is actually said to be the cation go here. So means this one must be the negative electrode. So I put a minus there. Alright. And then the anode will be the positive electrons. Okay, first we have to figure out what kind of ion is present inside the solution first. Alright, because this is a dilute, you see the word dilute, ethanoic acid, so means it has a lot of water. So means what are the ion we have inside here? Of course, the one come from water, we have H plus, OH minus. Okay, and then the one that come from this acid, we have H plus also, so it's repeating, and the other one will be CH3, COO minus. So these are some of the ion that present in the electrolytes inside. Okay, so now we're going to focus on what happened to the cathode, because the question only asks you what happened in the cathode. So cathode is where you're going to pick positive ion. We call it the cation. So can you see here? Only one positive ion. Of course, you are going to pick H plus because we're not allowed to choose. We don't have another one. Okay, so H plus will be attracted to this, and of course electrolysis, the ion will be attracted to the electrodes, and after that it will discharge. Discharge means that it will form something that is neutral. So from something that is charged, like positive charge, it will become something neutral. H plus, of course, will become just H, no more charge. But we know that hydrogen cannot exist in atom. At room temperature, it exists as a gas. We call it a molecule, so H2. And then there's a 2 down there, so here's only 1. So you cannot put 2 down there, because when we say balance equation in chemistry, we have to put a number in front. So here's a ratio that this side got 2. I need to make the left hand side also got 2. So I need to put a 2 in front here. Then after that, you have to balance out the charge. Make sure both sides will be having equal in charge. So here's already 0. We try to keep 0 here. And here, I also try to make it 0. 2 plus, then I add 2 electrons. Okay, so I plus 2 electrons. Just remove some of the thing here. Alright, so here we have 2H plus, so I'm just going to plus 2 electrons. So you can see that 2 plus, 2 minus, the left hand side is 0, here also 0. Then this half equation already balanced. So the 1 mark is actually come from here. Can you see or not? Because this one is come with how many marks? They say it should be 2 marks lah. So another one will be the name. Apakah yang terhasil di cathode? They want you to tell what is produced. So you can see the answer here. What are you going to produce? So you just write name lah. So we are going to get a hydrogen gas. So these are the 2 marks. Okay. Now we look at part B. Alright, so I'll just scroll up again here. So part B here, this diagram shows 2 types of cell. Okay, so when we learn cell, actually we have these 2 different types of cell. Compare and contrast cell A and cell B. They labeled it A and B. Include in your answer the observation and half equation for direction at the electrodes in both cells. Since they give us specific electrodes and the electrolytes, we can also predict what happened, what produced, and those observations also. So this one comes with 8 marks. Okay, so we try to give as many marks as possible. Okay, so it's good because it's said to be compare and contrast. So a table is actually suggested. So we just compare between the cell A and cell B. Okay. So first I'm gonna write a table, draw a table here. So we're gonna start with the cell A. So write this one as a cell A, and then over here will be your cell B. Alright, so cell A and cell B. Okay, first you have to know the name because they just call it A and B. So I think the first point you can always get is just by naming what is cell A, what is cell B. Okay, so I can just say the types. So the first point is about the type of cell A and cell B. So how do we tell? First, you look at inside the wire. You can see this cell A that connected to this V, we call it the voltmeter. But in cell B, they connect to this battery. So whenever you use battery means this cell is using electricity, while this one is producing electricity. So this is known as your voltage cell because voltmeter is used here. Okay, voltage cell. While for cell B since it's using electricity, so we call it electrolytic cell. Electrolytic cell. Okay, so this will be your first point. Okay, so let's draw a line here. And now, what are the other differences you can tell here? So it's like just now, this one using this one producing electricity, this one using electricity. So what types of energy change? So the second mark you can tell is actually to tell them what is the energy change, from what energy to what energy. So here is what happened is actually the chemical reaction that happened inside here producing electrical energy. So here the energy change is from chemical, it changed to electrical. Okay, electrical. And while here is the opposite, since I say I'm using electricity, so from electrical I change it to become a chemical energy. All right, so that is your second change. Okay, what kind of change also you can tell here? Then next, I think because here already we should have already 2 marks here already. So the second mark here, the third mark and the following marks, you can just explain what is the reaction happening in both separate cells here. Okay, so like first we try to figure out what kind of ion present in the electrolytes. Okay, as you can see here for this voltage cell, you have two different electrolytes, magnesium sulfate and copper 2 sulfate. So of course you're going to have different types of ion insides. Okay, but let's look at the electrode first. So I can see that this is your magnesium and copper, but here both are copper, so you actually can tell them. So but which one is the positive, which one is a negative? So for the first cell, the cell A, the voltage cell, how do we tell the difference, which one plus, which one minus? You have to compare the electropositive series. So which one is more electropositive or which one is more reactive above the series? So magnesium is more reactive than copper. So magnesium is the negative terminal. So the second one, the third point that we can tell is actually we can compare the electrodes. Okay, so for the anode, here we call it the negative. It's said to belongs to magnesium. So I just write symbol Mg. While the cathode, in other words, we call it the positive, is actually the copper. Okay, so negative terminal, negative electrode is magnesium, positive electrode is actually copper. Okay, now we move on to your cell B. Okay, for cell B, as you can see, both are copper. So basically both the anode, cathode are both made from copper. So you can just say here, your anode and your cathode are both copper. Okay, be careful with the sign. for anode here is not negative. The anode here is actually positive, while the cathode here is actually negative. So it's opposite, depends on the types of cell that you investigate. Okay, so anode is negative in voltage cell, but anode will be plus in electrolytic cell. Okay, so both are the same. So we have copper, copper. Okay, Cu. Okay, go up here, put it smaller. Okay, so this one is Cu lah. Okay, next we can actually try to figure out what happened. Okay, what actually happened inside your electrolytes. Okay, so by writing all the equations. So let me just put there the equation for that. Okay, equations. So start from the cell A. So let's see what happened at the anode. All the negative electrons. So since magnesium is more electropositive, so it will be undergo oxidation. So remember this principle, we call it the anox. So anode must be oxidation. So what is anode there? Magnesium. So magnesium will oxidize and form magnesium 2+. So we have a 2+ and 2 electrons by producing 2 electrons. So this is what happening at the anodes. Okay, let's go here. Next, what happening at the cathodes? Okay, cathodes. Cathode now is your positive. So just now I say already, for this one is anox. So anode is where oxidation occur. Cathode, you remember, is reduction. Red cat. Red is reduction, cat is cathode. So copper undergo reduction. But that's wrong, because a metal cannot reduce. Metal can only oxidize. So, but still, yet, cathode is a reduction process. So it must be the ion that reduce. It's not the metal reduce here. Then look at the picture again. And you can see that copper, this is the copper. So it's not going to use a copper, but you look at the electrolyte, inside is what? Copper 2 sulfate. So of course it's the copper 2+ that reduce, which gain electrons. Okay, so Cu 2+ plus 2 electrons, we're going to get Cu. This is what happened at the cathode. Okay, now we move on to the cell B. Alright, cell B, we have copper 2 sulfate solution. So means we have copper 2+ ion, SO4 2-. We also have the one come from water, so H+ and OH-. Okay, do the same thing here. We try to dissect what happened. So at the anode is actually at the positive electrons. So you have to decide which ion attract to the anodes. So you're going to pick the negative ion, which is anion. Anion attract to anodes. So what are the anion you have inside here? There are two. One is sulfate, one is hydroxide. Okay, but are we using any of this? No. You're going to pick hydroxide when you are using some electrode they are said to be unreactive. But as you can see, these two electrodes here, they are made from copper. So means now the focus is not on separating this solution, this compound anymore. It's more on like purifying the copper. So the copper now is actually involved in the reactions. So still following the same rule, anode is oxidation, follow the anox. So the copper oxidize. Cu become, okay, let me just erase again, write again. Cu oxidize becomes Cu2+ plus 2E-. so copper is oxidized. And then the cathode is the one that negative. So what happened to the cathode? The cathode will be reduction, red cat. So now you're going to pick the ion inside here. Which one is actually reduced? So we have copper 2 plus ion, we have H plus. So which one will be picked to reduce? So we pick copper 2 plus because it's easily discharged compared to hydrogen ions. Okay, so the CO2 plus 2 electrons will become Cu. Okay, so that will be the difference that what happened at the equation level lah. Okay. Next, they want also observation. So the last point you can comment is actually on the observations. Okay, so now what happened at the anodes? So you just write them the same thing again lah. So here you can see that the magnesium actually become thinner. So I put there lah. What happened at the anode? So the magnesium become thinner because it's dissolved and forming ions already. It become thinner. Okay. And okay, become thinner. And then what happened to the cathode here? So you can see that the copper is actually formed here. So you can say what? Copper plate become, because here is actually the copper is made from copper also, and then you are forming more and more copper. So the copper plate become thicker. Copper plate or copper electrode become thicker. Okay. And then now move on to the electrolytic cell. What happened on this cell here? So first we try the anode first. So what happened to the anode? As you can see, you can see the anode, the copper is actually dissolving. So the copper anode become thinner. Copper anode become thinner. Okay, so now what happened to the anode copper? So over here, this is a plus, so this is your anode, this is a minus, this is your cathode. So what happened to this cathode here? So the anode, the cathode, the copper cathode, the copper cathodes become thicker because you are forming more and more copper, become thicker. All right, so this is what overall what really happened in these two different types of cell. Okay, we first explain the different what types of cell and how is the energy change difference and what sort of electrodes are they known as, and of course the underlying reactions, equations, okay, together come with the observations. All right, so overall all this you should be able to get full marks for that. All right. All right, we're going to continue with the next question here. So that is a question for your part B. So this is your part B answer. Next, we're going to go to the part C. All right, scroll up here. We go to the part C. A student intends to electroplate an iron ring with a silver. All right, how to obtain a uniform plating? Okay. Before that, you can see that on part 2, now they want you to explain how you actually perform this electroplating. But first, how do you obtain a uniform plating? Okay, For you to obtain a uniform plating, several things. First, you must be able to understand is the theory behind this. Okay, so I'll just give you a quick theory here. What is actually electroplating here? So for electroplating, of course, you have electrolytes, okay? And of course, here you're going to have this, all right? And then here you have your long and short. So this is your plus, this is your minus, okay? And let's say you want to electroplate the ring. So which one should be your ring? So one is plus, one is minus. So of course the ring, you have to put it here. So let's say I'm draw a ring over here. So that is my ring. Okay, so let me draw again over here. So this is my ring. So make sure also the ring are fully immersed in the electrolytes. Something like this. Okay, so this is a ring. So means this is your positive electrode. We tend to call it anodes. So I put that this one is your anodes, which is positive. And then the ring here is on the negative, so it's negative electrode. We call it cathodes. And you are using a battery. So battery means this is an electrolytic cell. Okay. Depends on what you want to coat the ring with. So let's say I refer to this question. You are going to electroplate the ring with silver. So means your anode, the coating material must be made from silver. So they are using a silver anodes. So your ring is actually the iron ring here. So it will coat with this silver from here. Because the silver will oxidize, they will form the ion, then the ion will pick up here and it will reduce and form silver on the surface on the ring. Okay, so now you have seen what should be on your plus, positive or the negative electrode. But how about the electrolyte? So the electrolyte must contain something similar with the metal used here. The ion, the positive ions must have this similar one. So you can just say you use a silver. Just suggest any compound that is solution. So silver nitrate solutions. So that will be your electrolytes. All right, as you can see here, must be similar one, these two. Okay, so part one, now we can answer how to obtain a uniform plating. So first, there are two ways you can do that. So I'm going to put the answer for part one right now. Two methods what you can do. The first method is first, the surface of the ring you must clean. Make sure it's clean up. No impurity, no grease, no dirt, so that later the electroplating is complete, is perfect. Okay, so what you can do to obtain a uniform plating, so you say clean the ring and make sure no impurity, or dirts. Because if it's, let's say, not clean, it's very dirty, the coating or the electroplating will be not uniform, right? It may fall off, it's not complete, and so on. That's the first step what you can do. The second step, after you have cleaned the ring free from impurity and dirts already, and during this electroplating process, the ring is, make sure is of course fully immersed into the solutions, and on and off you have to rotate the ring, right? So means this part here, the ring, you have to try and rotate. Don't just leave it there for a few hours, right? So on and off you go and rotate the ring. Okay, so what you can say here, rotate, or you can say move the ring. During the electroplating process, don't move always lah. On and off you move a while, then you leave it, you move a while and leave it. All right, rotate or move the ring during electroplating. Okay, so these are the two ways you can do to obtain a uniform platings. Okay, next part 2 here, they want you to design laboratory experiments to electroplate the iron ring. Okay, your answer should consist of the following: procedure of the experiments, a label diagram showing the setup of the apparatus, okay, half equations, and at both electrodes and of course observations. All right, so we're going to answer these 4 parts here. So we're going to start with the procedure. Okay, so I'm going to write the procedure. So this is your part 2, procedure. Okay, procedure of the experiments. Okay, iron ring is make sure you know where to connect to your iron ring. As I show the diagram here, your iron ring is connected to the negative terminals. Okay, so iron ring is connected to the negative terminal of the battery. Okay, and then what is connected to your positive? Since you want to coat the ring with the silver, so you're going to use a silver plate, while the silver plate is connected to the positive terminals of the battery. Okay, so in other words, you can also say that the iron ring is basically your cathode, which is a negative. Okay, and your silver plate is actually the anode, which is your positive. All right, as long as the meaning is there lah. All right, so that will be your step 1. Okay, so I think I better put numbering here. So this is your step 1. Then what is your step 2? Because procedure means step by step. Okay, so once you have connected to the different side of the battery, one positive, one terminal, so the teacher or the examiner have figured out what is connected. So iron ring and silver plate. Okay, next, all this plate, so both plate are you're gonna put inside the solutions. Okay, are immersed into, okay, suggest a solution. As I say in the picture just now, since I'm using a silver anode, all right, the electroplating metal, so it must also found it in the solution. Silver and silver must be there. Okay, so both plates are immersed into silver nitrate solutions. Silver nitrate solutions. Okay, okay, the circuit is completed. Connect the circuit lah. You can just say connect the circuit and start the electroplating. The circuit is complete. Is completed for electroplating. So they want you to draw a very simple diagram. So I think I have drawn the diagram just now. So you can just draw this diagram. All right. So several important things you have to label is actually you can put ammeter if you want. All right. So you can put an ammeter if you want, and make sure these electrodes you immerse into the solution. It can be halfway or it can be fully. All right. But make sure the ring must be fully immersed. So this one you label lah. You label this one as well. So this is your iron ring. So both the electrode you must label. So this one is your silver plate, or you can call it silver anodes. then this one will be your iron ring as a cathode. Okay, and the solution they use here, you label as well. You call it silver nitrate solutions. Okay, so this apparatus setup will be functional and this circuit is complete. Okay, and it's ready for electroplating. Okay, next procedure we have done. A label diagram also we have done. Next, only two parts. We're going to look at the half equation, the underlying reaction for this. All right. So for the half equations, so basically you're going to explain what happened at the cathode. Half equations, I put the title here. What happened at the cathode and what happened at the anode. So we're going to start with the cathodes. Once again, the cathode is actually the negative one. And then what happened at anodes? So anode is the one that is positive. So remember, the iron ring is happened at the cathode. Okay, so you know that the iron ring must coat with silver. So you must form silver at the cathode. So the silver must come from silver plus in your solution. So remember also a very common rules that an ox, red cat. So the red cat means cathode is where reduction occur. So we have a silver plus ion in the electrolyte. They undergo reduction. By gaining electron, you are forming silver. So this silver will be coated on the cathode, which is the iron ring. Okay, next I call it an ox. So anode is where oxidation occur. And once again, look at what is made from anode, the silver plate. So the silver will oxidize by losing electrons and form a silver plus. Okay. So what is the observation? So you have to also mention the observation here. So I will just continue here. So I just put the observation behind here. So I'll just write here again. What are the observations? So first, at the cathode first. Cathode, what is observation? So you can say a silver solid is deposited because Ag is silver. So a silvery solid. Or you can say also a gray solid. All right. You can say, okay, silvery solid is deposited. Okay, now what happened at the anode? So anode, you can see you form a positive ions here. But this silver, you actually can see what happened. So the anode become thinner. Anode silver become thinner because it's dissolved. So means if I go back to the diagram just now, so this plate will become thinner and thinner because it's dissolving and forming a silver plus. And then the silver plus is actually coated on top of the iron ring. Okay.